So some of the exponent rules we went over last night, at this point we're going to then do a review on, and we're going to be doing numbers 13, 15, 21, 25, and 29. And I will label those as such on the video. So number 13 is a great example of one where the order matters so much. The first thing I'm going to do is put a 1 there. And I'm going to zoom in because the people who are actually watching this live can't see a thing I'm doing. We'll make it even bigger, but please don't look at my arm. That's just rude. All right. So on number 13, I'm going to put an understood 1 there, and I'm going to distribute that 2 out to both of those. That means I'm just going to rewrite that 2n squared. Just rewrite it. I haven't even touched it. And then I'm going to rewrite this as now 2 squared n to the 8th. So we just distribute that out. 2 times 1 is 2. 2 times 4 is 8. Now, let's just rewrite the 2, and we know that 2 squared is 4. Let's just rewrite that right now. If we can do some of this in our head later, that's just fantastic. But right now, we get a little confused. And now let's deal with our exponents. What is the rule if I have exponents and the same base and I'm dividing? Subtract. And what's 2 minus 8? So I have 2 problems left. Now this is right, it's just not done. So I have 2 problems left with this one, and I'm going to just write it over here so you can see it. So what are my 2 problems with this that I can correct? I can simplify it. Let's not even look at the variables yet. We know from back when we were in 2nd grade, 2/4 can be simplified to 1/2. So I'm just going to rewrite that, 1/2. Now what's the problem with n to the 6th? And to get rid of a negative, I bring it down and make it positive. And that's your final answer. Now, these in-between steps are up to you. If you're getting them wrong, I highly recommend them. If you're getting them right, I don't really care. Yes?
Okay, so you know how when we first started for the bottom part, we put a 1 behind the 2?
Yes.
Why do we put a 1 behind?
There's an understood 1 by every new base, if there's not an exponent there. Huh?
I have to put the 1.
And what happens if you don't put that 1 is you're going to forget that 2 becomes 2 squared. Now, it's not a requirement for me. It's just something I've seen over the years that people mess up the coefficients. Remember that the rule is to every new base. 2 and the letter n are 2 different bases. Meaning you had to multiply that out with 2 different exponents. Yes, ma'am? I will take that. It's not my favorite, but it's a right answer. Well, her question was, what if I wrote it as 0.5? But you'd have to write it. Be careful, because the only way you could write that is 0.5 over into the 6th. That would be a right answer. Okay. Number 15. Go ahead. Did you have, because they're not the same number, right? N can be a 5 or a 7. A 2 is a 2. Just like N and P are 2 different bases, right? 2 and 3 are 2 different bases, right? So anytime we have a different base, yes, that could be a 2. And if it was, we could add the exponents, but we can't assume that a letter is a specific number without solving it. Nice question. All right. Number 15. Number 15. My first thing is I'm going to put a 1 there and a 1 there. This 4 has to go to every single exponent that exists. Now, some of you simplified first, and that's fine. I'm going to distribute first. It doesn't matter which way you do it. That's going to give me 2 to the 4th, m to the 4th, over m to the 12th. Remember, when it's a fraction, it goes to the numerator and the denominator. So at this point, 2 to the 4th, just so we can get rid of it, is what? 16. 4 minus 12 is negative 8. I can't keep it as a negative, but did I have anything that's going to move that 16? Nope. So 16 gets to stay upstairs. But negative 8 is being sent downstairs to make it be more positive. No one liked their attitude, we sent it down to the basement. And we're left with 16 over into the 8. When you have a negative attitude, you get sent downstairs by yourself. All right? It makes you positive. All right? It makes you positive. All right. Number 21. If there was one problem I was asked more than any other that I would probably assume is going to be on your next quiz. It might be 21. Did you have a question before we got there? Go ahead.
Why did 16 have to
What 16 would have to have a negative exponent, does it? It doesn't have any, actually has an understood 1 at this point, right? There's nothing to move it downstairs. Only a negative exponent moves it downstairs. All right? So just think about it. You want to get away from a negative x. Okay? Negative exponent. All right. This number 21, again, it's why it's so important that you can just write that 1 there. I've got to multiply this negative 1 by everything that's in there. So 4 to the 1, what is 1 times negative 1? Negative 1, right?
Yeah.
And then x to the negative 3, what is negative 3 times negative 1? Positive 3. Well, this is new. He's positive, and I know I'm going to have a fraction. That's what someone I think said either this class or the other class. They said, can I just assume I'm going to have a fraction? Yeah. If you see a negative exponent, it's fraction time. All right? So I'm going to have x to the third, and that negative 1 moves that 4 downtown, downstairs to the basement. And I can rewrite that just as x to the third over 4. The question that keeps coming up is, can I leave it as 4 to the first? Yeah, I don't care. You're not going to see that way multiple choice, but open-ended is fine. I can tell that these mean the same thing. Yes, yes, that's the other thing that people keep asking me. Can I leave the 1 in front of the x? That's also fine. Great question as well. Yes. All right, number 25. All right, 25's got two different things going on. Again, this one's a little, there's nothing to distribute on 25. All right, nothing at all. So on 25, I'm going to look at my coefficients first. They're not the same base, right? So what is 4 divided by 2? 2. So I can just write a 2 over here. I can write my fraction in case I'm going to need it, because most of the time I do. Now, what is the rule? That if I have the same one, I'm supposed to do what? Subtract, which means I would have, and I'm going to do a little thought cloud here. I would have m to the 0 minus negative 1. It's keep change, which makes it plus 1, which means m to the positive 1. I end up with nothing on the bottom. And my answer just becomes 2m. So I started by simplifying, then I did the exponent part. Now the other way you could have done this that I saw some people do it is the minute they saw m to the 0, they called it 1. Then they just brought the m to the negative 1 upstairs because it was negative. Either way will give you the same answer. All right, 29, or as I like to call it, my age. 29, we're going to start. That was not a joke. Pretty ugly. So let's start by doing our power to a power. 0 times negative 4 is what? So I'm left with x to the 0. Anything to the 0 power is? Anything to the 0 power is? 1. So I'm just left with x squared. Or you could have said 2 minus 0 is 2. Either way, you're left with x squared. This is one that's a lot easier than it looks. Go ahead and ask Nicole. Oh, I mean student who we do not know.
I'm confused because I thought you did the negative 4 to the x.
No, because the parenthesis was not around the whole fraction. What a great question. So it's only these two right here. That 0 is already with that x. You can't give that x a new exponent. It already had one. Okay? Great question. Very good question. All right, and those were the exponent ones we asked for. Yes, ma'am.